So LLMs are language-based foundation models that identify patterns in text. And we can think of them as having a general purpose language understanding. So to put this into context, you can think about traditional or non-foundation machine learning models. So for example, consider a classifier to determine if an email is spam or not spam. In this case, to train it, you would need to get a lot of data, and then for each email, you would need to manually determine if it's spam or not spam using your brain, and then label it accordingly. And once you get enough data, and it's hard to tell what's enough, it could be hundreds, it could be thousands of observations, then you would pass that data into the traditional machine learning model, and it would learn patterns in emails that would help it to predict spam or not spam on new emails. But this model can only be used for this specific case. This model can only determine if an email is spam or not spam. And this contrasts to large language models, which are general. And so they can either be used by themselves or as part of a larger model on any natural language processing task that requires an understanding of language. So LLMs are a type of natural language processing, or NLP, model. Natural language processing is a subfield of AI that tries to understand and extract insight from textual data. And a necessary step in any natural language processing model is the conversion of text, which is human language, into numbers, which a computer can understand. And this conversion is called vectorization. And in the context of LLMs, the resulting vectors, which are just a list of numbers, are called embeddings. And when we do this conversion, we want to keep as much context in the text as possible in our numerical representation. So you can think about it as text is a sequence of words. However, the full meaning of the text is not determined by how many times each word showed up. You need to take into account the fact that the meaning of each individual word is determined by all the words around it, and it's all interconnected. So that's the context I'm referring to. And previous methods of vectorization before LLMs lost most or all of this context. And so where LLMs really shine is that through this vectorization technique that LLMs do, they keep this context at an unprecedentedly high rate, and then you can use those contextualized embeddings to power machine learning models that can have much higher accuracy than non-LLM based models. LLMs are called large language models, and they're large in two senses. The first sense that they're large is in the amount of training data that they need to be trained. These are foundation models, so they're self-supervised and can identify patterns without relying on manually labeled data. And I want to emphasize here the burden that manually labeling data has on building machine learning models. So manually labeling data is an expensive process, both in terms of time and also resources. So imagine a human going through thousands of observations of text and reading each one, thinking about it, determining what category it belongs to, and then assigning it that label. That takes a really long time. But also not all humans have the knowledge required to sort text into certain categories. You might need certain domain expertise, and you might have limited access to domain experts. And so getting enough labeled data for your machine learning application can be a real bottleneck. And so I want to point out that even though LLMs require a massive input of training data, the fact that that data is unlabeled relieves the massive burden that manually labeling training data had on machine learning applications. LLMs are also large in the number of parameters that they have. Parameters are values that the LLM learns from the data. We can think of these parameters as being little knobs that can be tuned just right to get the output of the model that you want. And these knobs are set automatically through the self-supervised training process. And at the end of the training, the knobs will be set in such a way that they encode information about all the words that the LLM learned in the training process, but also all the context that that word might show up in. And then once the model is trained and the parameters are set, you can then run new text through the model, and the parameters will all work together to produce optimal embeddings, taking into account the context that the words are in and all of the knowledge that the LLM gained through the training process. And I want to point out that in general, more parameters leads to more linguistic nuance that can be captured by the model. LLMs are trained for a general purpose, and we can think of them as understanding English or any other language whose data they train on. But I want to point out some things that an LLM does not do. So an LLM does not know any facts. There is no database of correct human verified facts that an LLM, when being used generatively, can check against before generating output. It will just generate the most probable output based on the input, regardless of if it's true or not. And the LLM, since it's trained generally, does not have any, is not tailored to our specific use case. It does not have any specialized understanding of our business or business case. But the flip side of this generality is that the LLM can be harnessed for a wide variety of tasks. And these tasks that an LLM can be harnessed for fall generally under two categories. There's generative AI and non-generative AI. And what these two have in common is that the LLM first takes an input and understands it by generating these contextualized embeddings. And then for predictive modeling or non-generative AI, we can use this understanding to power very accurate machine learning models. And then in the generative case, once the LLM basically understands the input text, it adds an additional layer of producing novel output in response to the input. So now I want to talk more about specific applications. For generative AI, you can create short summaries of long documents. You can get your questions answered like you might see in a chat bot. You can translate English into Spanish. And then for non-generative AI, you can classify reviews into positive or negative sentiment. You can recognize different entities in text based on how they're being used. So, for example, differentiating between Apple, the company, and Apple, the fruit. And then you can also use text similarity to get more accurate search results. And there's many more applications beyond just these.